Well, good morning and welcome to the lesson. If you notice, we're going to kind of do something a little different this week. What we're going to do is actually teach from the actual lesson plan that you guys see and be able to run through each section together to kind of give us maybe some more understanding of what's expected and how to work through the lesson plan itself. So again, just like every video that we have a learning target. This lesson is going to be on similarity, which is kind of the second term in that new unit. Last week we talked about dilation, and this week is going to be similarity. So again, I can explain why two transformed figures are similar based on their sides and angles. So again, some of this might be review from the previous unit when we talked about congruence, but it's just a different word to kind of see what does the word similarity mean, and can I explain that based off of the transformations of figures off their angles and sides. So if I look at the engaged part, why do you think these two figures are similar? So again, I'm telling you that they're similar, but why do you think so? Even though they're rotated differently and they're moved around differently, can we look at the sides and angles and determine, are these figures similar and why? So again, that idea of why things are the way they are. And in math, it is so important to be able to explain why in the greatest detail that you can of why you think something is. So be able to think of that. And again, use this to kind of drive what you want to know in the explore section. You know, why are these similar? If I don't know, why are they? Well, to the explore section, we have a bunch of resources that are going to help us. So if I look at this video, it's going to better help you understand what similar figures are and what to look for. So this is an additional resource for you to watch to be able to get that understanding a little better. And what we're going to do in this lesson is kind of look at the read and practice. So if I look at the read, what we're going to do is understand similarity with transformed figures. So if I go to this little page here, it says that figures of the same shape but not necessarily the same size are said to be similar. So if I look at these two cartoon dogs, they're not exactly the same shape but are not the same size. So the dog on the right is an enlargement, and we've talked about dilation last week. They are similar figures. So we say that polygons are similar if their corresponding angles are congruent and the ratios of their corresponding sides are proportional. So if we look at the example below, we're kind of looking at the idea of triangles, okay? So if we look at these two triangles, we can see that what we're going from 6 to 9 to 4 to 6 and 3 to 4.5, using this idea of sort of like our scale factor here, 2/3 being multiplied by these numbers correctly gives us these numbers. So we would say their corresponding sides are proportional, and we've kind of already talked about that a little bit in our last unit. And we've already kind of seen this idea that if these are increasing by the same number, the sides, then they are called corresponding sides, right? They're the same side. Angles are the same way. Even though something is getting bigger, the angles to these letters stay the same as well. So we say that they're congruent or they're the same. So if this is the case, all right, we would say that these two triangles are similar, all right? And there's kind of a little symbol there we could use. It's that little squiggly line to say things are similar. So if I look at these two triangles, again, the idea that the sides are increasing by the same number, scale factor we call it, and the angles are similar, makes these triangles similar. So if you kind of look again, and there's some examples down there, are these triangles similar? If it is possible to find one or more transformations that will move one triangle to coincide with the other, the triangles will be similar. So if we kind of look at this idea, when I go from 8 to 16, 10 to 20, 6 to 12, they're all increasing, or they're all doubling, or they're all increasing by 2. So it would make these triangles similar, and the angles themselves are the same as well. So looking at this idea of similarity, all right, you're going to be able to practice by looking at these shapes. Are these shapes similar? So again, what we need to look at is are the sides increasing by the same number, and are the angles matching up to the corresponding sides, right? Are they all matching up the way? Is the single line matching up to this one? Is this one matching up to this one? Or is this one matching up to this one? And are the sides increasing by the same side? So again, the angles and sides play a key factor in this understanding. So kind of looking through this, if we go back to the engage part and look at this, Again, can you answer why are these two figures similar? Even though they're in different orientations and the size may be enlarged, are they similar figures? So what you're going to do through this lesson is, again, the explain side. You're going to click on here. And again, instead of doing a Padlet this week, what we're going to do is I actually found a quiz game that you're going to kind of click on, and there's some directions here for you to follow that's going to kind of help you practice this idea of similarity, all right, in kind of a fun fashion. Instead of doing a Padlet and have you kind of type out, I'm going to have you actually do a fun little quiz game to kind of develop your understanding and to be able to explain what you've learned in these explore section. For the checkpoint, what I'd like you to do is, how do you know? Again, how do I know? Well, if I know they're similar, how, right? So kind of developing those explanations and the importance of being able to share what you know and why you know it to be able to do that. And in the elaborate section, what I found is a real world activity to show your understanding of similar figures with sides and angles. So you'll be able to click on that, and there'll be directions for you on that document to kind of help you follow a real world application. Where do I see this in the real world? Where can I use this understanding? But again, in that activity, think of the way of why are these things similar, or what is the similarity? What is the importance of the similarity in this example? And be able to go back and answer that learning target. I can explain with confidence two transformed figures are similar based on their sides and angles. And then again, we'll wrap up with a express question. Always looking for ways what we liked in the lesson, what things helped us improve, what resources we used to kind of help us move forward. So again, hopefully you were able to answer this question at the end with confidence. And if you have any questions, please share. Continue making goals, continue working through this new unit. If you have not finished the previous unit, keep plugging along. And remember, we're based off of progress. We want you to finish these units and develop a deeper understanding of them and not just fly through things. If you have any questions, please reach out, and hopefully you guys have a great week.